Hello, my name is 𝗦𝗽𝗲𝗀𝗀𝗀, Vice President and General Manager of our ThinkEdge division here at Lenovo. Let me talk to you a little bit about edge computing, and let me start with perhaps the most basic definition of what is edge computing. In essence, it's the computing capability that we traditionally find in the data center, but now operating outside of the data center. That could be in gas station, in retail store, in restaurants, or oil rig in the middle of the ocean. And that's really important because the massive amount of data being generated at the edge has to be processed at the edge in order to deliver the most value. And at this point, a lot of customers look at me and say, well, hold on, we started in a mainframe, we migrate to a client-server architecture, we just completed our cloud migration, and now here you are, Charles, talking to us about edge computing, which is reintroducing computing capability closer to where the users are using it. Well, we're not that crazy. If you think about it, the compute capability always followed where the data reside. In the context of a mainframe, it was in one location, the compute and the data. Client server, same thing. Now in the cloud, that's where we store our information, and this is where we create it. But in reality, the amount of data being created at the edge right now is massive. It's exponentially larger than what we ever created in the cloud. Why? Because we have high-definition cameras monitoring areas or filming 24/7. The amount of data that generate is massive. And that's why we need to introduce edge computing or compute capability at that location to analyze that data, make a decision, or take an insight. That's really important because you'll find out that some of the locations don't have the network connectivity to bring all that data from these cameras all the way to the cloud. Simply impossible, right? There's too much information to move around. Some use cases will say, well, I need to have a time to decision that is much faster. I cannot wait for moving the data from the edge location to the cloud, process it, and return the information. We need to process it right then and there for a faster response time. So that introduced new challenges. As you can imagine, having the servers traditionally deployed in data center, we have a control room with temperature, with humidity control, security, and all of that. Now we take that same compute capability and put it somewhere closer to the user. Like I said, it could be in a truck, a boat, could be in somewhere in a restaurant or a store. So we need to have a set of engineering or a set of equipment properly engineered to operate in that environment. That's why at Lenovo we created our ThinkEdge brand. ThinkEdge is specifically designed to equip servers to operate outside of the data center. We took the best know-how and expertise of all our division to create that ThinkEdge portfolio. First of all, from our laptop colleagues, we learned how to design very compact, very ruggedized, very small form factor equipment that we can produce in our factories, massive scale, right? So we carry those laptops in the backpacks, we drop them, we spill coffee, and they keep running. So that is truly ruggedized. We learned a lot from our Motorola colleagues, our mobile division, that helped us design wireless antennas that are effectively able to communicate to and from the servers without having Ethernet connectivity, and doing this at a very high speed and high capacity. And finally, from our data center or infrastructure group, we learned how to design the most performant and most resilient compute capability so that we always have the most performance at the edge site and don't have to maintain them very often. So all these divisions, all this engineering, craftsmanship, and know-how came together to create our ThinkEdge portfolio. That ThinkEdge portfolio actually ranged from the SE30, SE50, SE70, SE350, and SE450. All of these portfolio is designed to operate in difficult environments, sustain a high level of shock and vibration, operate in extreme temperature. We also designed a lot around the acoustic. You might not think about this, but if you have ever visited a data center, you'll recall the sound it makes. It's pretty loud, pretty annoying. We designed our ThinkEdge portfolio to operate below 45 decibel because that's a normal office conversation, and you shouldn't notice there's a server operating in your office. We also focused on security. Quite honestly, our data center are protected with fence, with guards, with locked door, with biometrics to open them, and so on. Now that same compute capability is somewhere outside near the users. So we designed the device to be able to protect themselves and the data it contains. We have lockable screws, we have lockable bezel, we have lockable cap that or cover that you cannot open without having the proper key. We also encrypt the data. So the full system is encrypted, and we put motion detector in them. So if somebody steals the server, the motion detector is triggered and the data is completely locked up, right? So in that context, not only the physical equipment, but also the data is protected. That ThinkEdge portfolio is also able to communicate with the wireless capability. I've mentioned Wi-Fi in some hard to reach, hard to connect location where there's no Ethernet cable. We can use Wi-Fi 5 or Wi-Fi 6. We also have a remote management capabilities using a SIM card. You can have a SIM card installed in the server, and you could dial in to the server from anywhere in the world. That's really important because if you have to do maintenance on the server, it's annoying to walk in the data center and perform it. But if you have to drive for 6 or 7 hours to reach that location at the edge, it's even more annoying. It's a major disturbance. So you could dial in and take remote control of the server from anywhere in the world if you have installed a SIM card in it. So all of these attributes really created our ThinkEdge value proposition to our customers. Now we're often asked if edge computer is a reality or just an experiment. And let me share with you a few use cases that really show you how we move from pilot to massive scale deployment of edge computing. I'll start with the 𝗦𝗽𝗲𝗀𝗀𝗶cie Island. That's a use case that I love because it really shows the importance of bringing the compute capability closer to where the data is actually created. That island is 700 kilometers off the coast of Chile. Only has limited network connectivity via satellite, right? This island is unfortunately facing a challenge on the biodiversity because there's an invading species on the island. Some of the researchers from the Island Conservation Group are monitoring the situation and taking preventive action against that invading species. They set up some video camera traps all over the island and are monitoring the forest 24/7. And they're capturing snapshot of the animals as it walks by. So they're able to identify which area of the island where they need to focus their attention. Well, that's all good, but in order to get the data, to get that insight, they retrieve the data manually, put this on a plane twice a month. That data is leaving for the main continent on Santiago, where a supercomputer is actually processing all of this information. 2 weeks later, that data is sent back by plane to the island, where the researcher on the island can take an intervention and know which area to focus on. Well, we're able to take that data, instead of sending it to the main island, process it right then and there on that location. As you can imagine, this is not a data center facility. This is an environment, a room temperature that it gets very cold, very humid, very warm, and the server is yet operating in these harsh environment. We're able to process that massive amount of data generated by the cameras within a few minutes, a few hours. So the researcher directly on the island can take a corrective action and preventive action in a specific area of the island and not have to wait weeks, but are able to take this action within a few hours. So that's one of the examples that I want to share with you where the importance of having quick time to insight is extremely relevant. Not having to bring the data to a central location, process that, and return the information. Instead, we process that information directly on the island. From the most remote island in the world to perhaps your favorite fast food restaurant in your neighborhood, edge computing is really enabling a lot of these use cases. In the context of the fast food, if you want to enable the drive-thru experience, we'll have some ThinkEdge servers directly into the restaurant connected to cameras that are monitoring the drive-thru area. The video are capturing what's going on, the servers are analyzing and recognizing the object. This is a black Toyota Corolla with this license plate number. When the person pulls up at the microphone and places their order in Spanish or in English, the servers are automatically processing the translation. They're also doing the voice-to-text translation so that the order is directly placed to the kitchen in real time. And when the driver or the car pulls up at the window, the person operating the drive-thru is able to match the black Toyota Corolla license plate with the bag that they need to deliver to them. That means that this entire drive-thru experience is 85% of the time without any human intervention in less than 5 minutes. We also work with use cases with partners like Doctors Without Borders, who are using our ruggedized edge servers into some of the flight cases that are shipped all over the world, literally parachute or put on jeeps and bring into makeshift clinics to deliver health services. The physicians are expecting the same compute capability that they would expect in a hospital in the middle of a city, but this is in a very middle of the jungle, middle of the desert, right? So again, the Lenovo ThinkEdge portfolio has been designed to operate and deliver the performance and the reliability in these harsh environments. Let me share with you another use cases in smart agriculture, where I had the privilege to talk to some of the fishermen in the Gulf of Mexico who have our ThinkEdge servers directly on their boat. When they go to sea, they don't have network connectivity or very limited network connectivity. As they empty their net from the catches of the day on the boat, they sometimes, unfortunately, catches fishes that are too small to be legally captured, or some of the endangered species that are illegal to fish. And it's only when they get back to harbor and to the port, if they get audited, then they get a fine because they caught on illegal fishes. Of course, they do this accidentally, and that's not what they wish. Now, by having ThinkEdge servers directly on the boat, connected to cameras, we're able to process the video feeds from these cameras and measure in real time the size of the fish. Also recognize if we have caught an endangered species and notify the fishermen right away so they can throw those fishes back into the ocean at that point. So this is one example where, again, the servers are operating in a very humid environment, salty environment, movement, there's a lot of shock and vibration, as you can imagine, and yet deliver the performance and the reliability that you would expect from a data center, a server in a data center, but operating on a boat in the middle of the Gulf of Mexico. So with all of this, I wanted to share with you that the Lenovo ThinkEdge portfolio is really designed to operate in some of the most remote islands in the world, on fishermen both, in health clinic, in drive-thru fast food restaurant. All of these use cases rely on high level of performance that you would expect in the data center or in the cloud, but much closer to where the data is created so that we can process it, get the insight, and deliver value to our customers right then and there. So we continue to innovate at Lenovo, and we're happy to be partnering with you today. Thank you.